quadratic functions now, okay? So there's a lot of things to do on here. This is sort of putting it together. And if you missed last time, I've got the video for part 1 posted in D2L. So you can look at that if you need to review any of this. Okay, so what we're going to look at, we talked about this a little earlier this semester. You may remember completing the square. I'm going to show you a couple of ways to do the graph. And what our goal is trying to learn functions good enough. If you're in a higher level class, which might be one day, then you need to know functions and know it well. Okay, so I'm going to show you a couple of ways to go about doing this then. Okay, so what I would suggest you do is go down to this bottom right here and write the problem out. So we've got f of x equals x squared plus 4x and then plus 8. So I'm going to show you 2 ways to find the vertex. The vertex is where the parabola comes together. So we're going to be looking at that. Okay, so here's what you always want to do when you complete the square. You want to look at this term right here. It's important you look at that term. That's the term that's in front of x, and you always do 2 things. You divide that term by 2. So you want to divide that by 2. Then you square it, and when you do that, you get a perfect square. Okay, so I just kind of do this at the side here. So what you want to do, and you can do this in your head, you take 4 divided by 2 and you get 2. Then if you take 2 to the second, you get 4. Okay, we've learned that before. You just take half of that and then you square it. Then what you want to do as you're completing the problem is you do this. F of x comes straight down. So you want to have x squared plus 4x, bring that straight down. Now this 4, you want to do this. You want to add 4 to both sides. You don't do it to both sides. You do opposite things on the same side. So this is a little bit different than what we did earlier. So we do that. Okay? And by doing that, I have not changed the problem, right? Correct? Because in a sense, that would go away, right? 4 minus 4 is nothing. So what you're always doing is you want to work on this side. You want to keep that side the way it is. Okay, so what did I do again? I take half of that to get 2. 2 squared gives you that 4. Add 4, subtract 4. Does that make sense? If you don't put that subtract 4 there, you're totally changing the problem, right? Okay, so what you want to do here, when you bring this down now, is this. Okay, bring the f of x down. All right, that's going to be just always coming down. Now put a parenthesis around the x squared plus 4x plus 4. And then you got 8 minus 4 is plus 4. Okay, so that's how that goes then. All right. Now what we're going to do is factor. So we've been doing a lot of factoring this semester. So when you factor the x squared plus 4x plus 4, okay, we need to factor that and just bring the 4 down. So if we draw 2 parentheses on that, okay, then we'd have x and x. Okay, we'd have 2 numbers that multiply to give 4, which would be 2 times 2 to get that 4. Okay, and like we've learned earlier, notice that inside term's 2x, that outside term's 2x. How do you make 2x and 2x add up to positive 4x? They're both positive, right? Okay, now what's going to happen when you complete the square? That factoring is always going to be the same factor twice. If it isn't, you're screwing up. Okay, so you have to be aware of those kind of things. So what we're going to have now is we're going to have f of x. Now rewrite this part right here as x plus 2 to the second plus 4 like that. Okay, now that's what the procedure is of completing the square. And the reason we do that is because now we know what the vertex is. So I'll talk about that. So let me just kind of talk through what I did again. The term in front of x is what you complete the square on. So again, what did I do? I took half of the number, 4 over 2 is 2, then I square 2 to get this 4. Okay, that's where that comes from. Now, why did I put this minus 4 here? To balance it out so I'm not changing the problem. Then I factor this to get this, and then 8 minus 4 is plus 4. You guys understand the procedure? What I'm doing there. Okay, because we'll do this, I'm going to show you an alternative way to do that, but if you catch on to that, there's a big benefit of learning to do it that way. So now what you want to see is, when you have the vertex, we have this general form. We call this the vertex form. So I'm just going to erase this right here for a second. And the big work of this problem is figuring out what the vertex and the intercepts are. Okay, so what we learned, like last week when we were going over this, we have what we call the vertex form. And the vertex form goes like this. Okay, so it's f of x equals a times x minus h squared plus k. And the vertex of the parabola comes from these two numbers right here. Okay, you get the vertex is hk. Now, here's the way that I think you ought to learn this, because we've learned about transformations. So if you remember your transformations, it'll help you. What does that plus do to the graph? It's either left or right. What does it do? Left. Okay, what does that do? Up or down? Up. So you're really going left 2, up 4 from the transformations we learned. So that means your vertex on this is going to be your vertex, by looking at this, is going to be -2 because you're moving to the left, and then +4 because you're moving up. So you want to record that as -2, 4. Okay, you want to understand that it's all about transformations. And really, in the form, you just use whatever that is. It'll come down, but that's always going to be the opposite. Okay? What's that?
Explain why it's -2.
Yes, okay. There's a couple of ways to do this. One way is that's left 2, right? So if it's left 2, that's moving you to -2. Okay, you're moving the point to -2. And if you're up 4, that stays the same. The other way to look at it is this is the general form, which says you're going to use the opposite of that number. See, this right now says +2. So if you wrote it in this form, it would be -2. That's the other way to look at it, okay? So we got our vertex now, all right? So what you want to do next here is we want to go ahead and just take the graph that I gave you and plot that point, okay? Go to the left 2 and then up 4 and then just label that point, okay, like that. Okay, so that's a big work of the problem. I'm going to show you an alternative way to do that here in just a minute. Okay, now the other thing I'm going to go ahead and do is this part D. That's called the axis of symmetry. So what we do is you draw a dashed line directly vertical through that vertex. Okay, and then the equation of that, we call this the equation of the axis of symmetry. That would be x equals -2. So when you name a vertical line by x equals something. So that's x equals -2. All right, so that's the vertex. That's the whole key to doing this. And then we're going to look at a few other things like the intercepts. But before I do that, when I ask you to find the vertex of a quadratic function, there's two ways to do it. That's method 1. Some students like that, some students don't. I think most students prefer to do -b/2a. So that's what I'm going to show you next, just to show you would get the same answer anyway. So down in this space, go ahead and just write down the function again, which is f of x equals x squared plus 4x plus 8. And remember when we were learning how to solve the quadratic formula, a is the number in front of x squared, b is the number in front of x, which is 4, and then c is the constant number, like that. So we learned that from when we learned how to do the quadratic formula, right? Okay, a, b, and c. All right, next thing you want to write down is write down -b/2a, and then we're going to calculate this, okay? So what we do is we have the negative comes down, and then we have b is 4, so that would be -4. Then 2 times a is 1. So I just write down -4 over 2 times 1. Okay, just do what the formula tells you to do. You would get -4 over 2. So that would give you -2. Now, what I want you to notice is that is the x value of the vertex. So if you do -b/2a, you should get what the x value of the vertex is. And I think most students find that easier. What do you think? So let's work. -b/2a gives that to you. Okay. Now, that would leave you with, how do I find that y value? Well, what we do is, if we know the x value is -2, then we just do f of -2. So you're going to take the -2 that we got from negative b over 2a and plug it into your equation. So we would do -2 squared plus 4 times -2 plus 8. That would be 4 minus 8 plus 8. Okay, and if you work that out, that would give 4. Okay, so what I want you to see is the negative b over 2a gave you the -2, and then plugging it in gives you the 4. So I don't care which way you do it. I think there's benefit in learning how to do it both ways, though. But most students seem to prefer negative b over 2a because it's less work. Okay, what do you all think? Any opinion? I think negative b over 2a is probably a little easier. You just remember the formula, you got it. Okay, all right. So as I'm working these problems out, those are going to be the things that I'm going to be showing you as the completing the square and then this method right here. So down kind of at the bottom of your page, the other thing we need to do is we need to find the x-intercepts and we need to find the y-intercepts. You need to find some space on your paper to do these two things right here. So really, when you graph a quadratic function, you need to find the vertex. That's the key point, is the vertex. And then if you can find the x and y intercepts, then you got everything you need, usually. Okay? So when you find an x-intercept, what you always do is you set the function value, f of x, equal to 0. Okay, so what you're going to do is take the original problem, which is f of x equals x squared plus 4x plus 8, but replace that f of x with 0. So you want to write down 0 equals x squared plus 4x plus 8, like that. And then you got to solve that equation, okay, which a lot of times means that you have to use the quadratic formula, because that thing right there doesn't factor. X squared plus 4x plus 8 doesn't factor. You won't be able to do that. So what you have to do is go to the quadratic formula, okay? So let's go ahead and do that. I'm going to write down the quadratic formula over at the side here. You don't have to write that down unless you want to refer to that. So that's negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, we've learned that before. We already know what a, b, and c are. Okay, so plug it in. You're going to have x equals negative b. B is 4. That's the number in front of x. Then plus or minus square root of b squared. So that would be 4 squared. B is 4. And then 4ac. A is 1. C is 8. Okay, and then you would do 2 times a, which would be that then. Okay, so I'm just taking the quadratic formula, replacing b with 4, a with 1, c with 8. Okay, you guys remember that? Okay, you'll have to do this from time to time. All right, so we work this out. We're going to have negative 4. Now, you could do your calculator for this part that's under the radical. If you do 4 squared minus 4 times 1 times 8, you get 16 minus 32, so you get negative 16. And when that happens, that kind of makes the problem kind of nice. It actually does in some ways. Okay, so let me ask you a question on this. What do you know about the square root of a negative number? Can you do a square root of a negative number? No, at this point, no. So that, because that's undefined, we know this part right here is undefined, then that would mean that we have no x-intercept. So what this is going to tell us is when we draw this graph, it's not going to touch the x-axis, okay? So what we need to do for your answer on the x-intercept now is we'll just say that's none for that reason, okay? So again, when you find an x-intercept, what you do is take the function and set the function equal to 0 and solve the equation. Your choices on that are going to be factor or quadratic formula. That's what's going to happen. Okay, is there questions on that? Anybody? Okay. All right, now let me show you how to find the y-intercept. Okay, so the y-intercept, what you do is you set x equal to 0. Okay, you're just setting the opposite variable equal to 0. So what you want to do is really find f of 0. Okay, so just go directly to the function I gave you, which is x squared plus 4x plus 8. Replace all of those x's with 0. And it's always easier to find a y-intercept than it is an x-intercept. You can do that arithmetic in your head. What's the answer to that arithmetic? That's 8, isn't it? Yeah, you can do all that in your head. So that means your x-intercept, or I'm sorry, your y-intercept is 8. So when I have you write an intercept, I'm always wanting you to write that as a point. So remember, we let x be 0. So you write the point 0, 8 like that. Okay? So that's what we've got so far. So what I've shown you is the big work of the problem. Finding the vertex, 2 ways to show that. Finding x-intercepts and y-intercepts. That at a minimum is what you have to do. The rest of the problem we'll figure out once we do the graph. Okay? Okay, questions on what I've done with intercepts? I can't tell. Are we good or are we not good? I'll find out in a minute because I will have you do a few problems on these today in class and see if you follow what I'm doing. Okay, so what you want to do now is you want to go back to your graph. Now what we're going to do is take that y-intercept, which is 0, 8, and then just graph that. So that would be like on the y-axis, label that as 0, 8, like that. Okay, now we don't have an x-intercept, which is okay. But the thing is, look how this symmetry goes on this. The vertex has an x value of -2. If we go over 2 units, we're going to be at that point. So if you just go over 2 to the left and then up 8, you'll get another point. And that point right there would be -4, 8. So again, if you find something on one side of the axis of symmetry, you can find the point on the other side. You can, okay, just count. So y-intercept was over 2 to the right, so the other point's over 2 to the left. Does that make sense what I'm doing? That's what the purpose of the axis of symmetry is. Now go ahead and just connect the dots, and you're just going to connect it like that. And notice that we didn't cross the x-axis, so the math didn't lie to us, okay? We ended up getting that square root of -16 in the quadratic formula, and that told us we have no intercept. Okay, so that's how that goes. Okay? All right, any questions? Now, see what we're trying to do on this, we're trying to learn. Those of you who are like STEM majors, if you're going to take physics, quadratic functions are a big deal in physics. They're a real big deal because that's how projectiles, work when you throw things. Projectile motion, it comes from a quadratic function. Okay, so it's good to get a good handle of these things. Now, the rest of the stuff we've already learned. The domain would be what x can be. X can be anything on a quadratic function. Okay, there's no 0 denominator. Remember, you're looking at x squared plus 4x plus 8. X can be anything. You can plug any number in for x, and you'll get an answer back. Okay, let me ask you about the range. Look at my graph. What's the lowest value of y that we ever hit on this graph? Well, it was 4, right? So what's the range? How are you going to write that? In 4 to infinity. Good. And you have to include the 4. So make sure that you have the bracket on the 4. 4 is included. Okay. All right. How about increasing? Increasing is going to be from the low point forever to the right. So this part right here, I'll just kind of highlight this part of the graph. That's where your increasing is there. So you would say the x value is -2 and then to infinity. When you're naming intervals of increase and decrease, you're using those x values. Okay, so that's how that goes. And then decreasing would be this part of the graph where you're going downhill. So what we would say on that is that would go -infinity to -2 like that. So that's the complete problem that we're trying to learn how to do, is put all of our graphs together. The big work is vertex and x-intercept. Those are the hardest parts of the problem. Okay? All right, any questions? Now, you can, of course, graph these on your calculator. I'm not going to do that on every problem, but if you have your graphing calculator today, which you should always have with you, you really should, because I want you to learn how to use your calculator as well. And a lot of times students say, well, why can't I just put it in my calculator? Well, if you do that, you're not learning anything about a quadratic function, okay? Let's get our phones away too, so we don't need to be looking at phones right now, okay? All right, all phones away, please. Now, go ahead and put this in. So go to y1 and put in x to the second, and then plus 4x, and then plus 8. Okay, so you just put that in, and then a standard window. So a good way to do a standard window is just press zoom, and then go down to zoom 6. And basically you can see if we ended up with the right graph. And the thing is, you can look at your table of values the way I've taught you before. So if you go second graph, we can verify that all these points are on there. See, there's your point -2, 4. That's on there. We have the point -4, 8. That's there. We have the point 0.08. That's there also. So your goal on a problem like this would be only to use your calculator to check. Otherwise, you won't learn the pieces that you need to learn. Okay, but you can check. Okay, it's okay to use technology to check. Okay. All right, let's go to the next kind of situation here. And on the next page, we've got another type of quadratic function. I'm just going to give you about 2 or 3 examples of these. I'm going to do this one, and then I'm going to have you maybe try one problem to see how it goes then. Okay? Now, completing the square is a little bit harder on this problem, but I'm still going to show you how it goes. Okay? So go down in this space here and write down the problem. You have f of x equals -3x squared plus 6x minus 8. Okay, and again, you will probably prefer that we do this by negative b over 2a, but I want to show you how completing the square works on this. Okay, so here's what we're going to do then. To begin with, you're going to group these two things together right here. Group those two things together and factor out the -3. Okay, just kind of think about taking a common factor out. Okay, so I'm just going to kind of show something on the side here. We're going to take a -3 out because 3 also divides into 6. And it's important that you would take the -3 out, not just the 3. All right, so kind of think backwards. What do you multiply -3 by to get -3x squared? Well, you multiply it by x squared. Okay, so what you're going to have is a parenthesis and then with a 3 in front when you take that out. So we have -3 and then we have x squared. Okay, now think about this just in your head real quick. What would you multiply -3 by? So you would end up with +6. What do you multiply -3 by to get +6? -2, good, okay. So that right there is going to be -2x. Okay, and every time you factor anything, you got to learn how to check it. Because if you don't, you're just wasting time on the rest of the problem. Okay, I mean, just check it. Look at this. -3 times x squared is -3x squared. -3 times -2x is 6x. So we know we haven't screwed up, right? Okay. Now, watch this carefully because this is a place where students have a tendency to mess up. We're going to now complete the square. So you take that -2 like this. Okay, I'll do this at the side. What are the two things we do? We divide that by 2 to get -1. When you complete the square, take half of the number, then square it. So what happens if you take -1 to the second power? What do you get? You get +1, okay? All right, so you're going to put a +1 there inside the parenthesis. All right. Now, here's what happens on this problem, okay? A lot of times students think that I added 1. I have changed the problem by putting a 1 there. So I got to balance it out. A lot of times students are going to think, if that's +1, I need to have -1 to balance it out. That is not true. What I really added was -3. -3 times 1 is -3, right? So what do I put here? The opposite of -3 is +3. Okay, that will balance it out. You have to really pay close attention when you do that. So that's a -3 that we did. So that means we've got to put a +3 there. Okay, does that make any sense? Okay, you make sure that you don't change the problem. Okay, if you multiplied and collect like terms and put it together, you'd get the same as the original problem. Yes?
You always divide the middle number by 2?
Yes. It's always divide by 2, get the result, then square it. That's how you complete the square. Okay? Okay, so now it's going to go like this. You're going to bring this straight down, and then you're going to factor this. And then negative 8 plus 3 is going to be minus 5. Okay, like that. Okay, now look at the factoring. The thing that I told you on the factoring is these things have to be the same. They always will be the same when you complete the square. So I'm going to have x and x. What am I going to have here and here? 1 times 1, right? And then I've got to get the signs figured out on that too. Okay, so I've got x and x. I've got 1 times 1. And again, you're trying to make the inner term and the outer term add up to negative 2x. So what kind of signs do I have, minus or plus? Got 2 minus signs, right? Now, you don't have to show all that steps. I like students to get in the habit of, drawing how the inner and outer come together to that middle term. Okay, so now we got one more thing to do. Just kind of what we'll have is f of x is equal to negative 3, and then x minus 1 times x minus 1, you write that as x minus 1 squared, then you have the minus 5. So after you complete the square, that's what you end up getting. Okay, and we'll do the negative b over 2a here in a minute to verify that that's what you would get anyway. All right, is there any question on that? The better you get completing the square down now, the better it'll help you with things in the future too. All right, so now let's kind of see what we know on this. What does that minus 1 do? Does that make you go left or right? That makes you go right 1. Okay, so that means your vertex is going to have 1 as its x value. What does the minus 5 cause the graph to do? Up or down? Down 5. Okay, so that means that the y value of that vertex is negative 5. Okay, so when you do this, that's just right 5. That's why that's right 1. That's why that's 1. That's down 5. That's why that's negative 5. So your vertex, your first point is 1, negative 5. Okay, so we got the key point on a parabola or a quadratic function is finding that vertex. Okay, all right, now go ahead and take your graph and plot that point. So we go over 1, down 5, and then you want to label that point right there. Okay, so before I move on from this point, I want to ask you a couple of things. What does this minus do? What did we learn about a minus outside of a function doing to a graph? Makes it reflect. So what's going to happen is this parabola is going to go like this now. So you're going to have something that kind of looks like that. So we already know that it's what it's roughly going to look like. We just need to be a little more specific. Okay, let's go ahead and do the negative b over 2a part now. Okay, so down in this space here, just write down the original problem, which is negative 3x squared plus 6x minus 8. Okay, a is going to be negative 3. B is going to be 6, and we don't care about C because we're only doing negative b over 2a. Okay, so write down negative b over 2a. That's how you find the x value of the vertex. So we would have negative of b. B is 6. Then you'd have 2 times a. A is negative 3. That's going to give you negative 6 over negative 6, which is what? 1. Is that what we got when we did completing the square? Yes. See, it's easier. If you do it that way, you can do that real fast. Okay. So we got that. And then what we got to do is we have to do f of 1. So once we find the x value of the vertex, then we plug that 1 back into the original function. So we would do negative 3 times 1 squared plus 6 times 1 minus 8. That would be negative 3 times 1 plus 6 minus 8. Use your calculator if you need to. You probably shouldn't have to use a calculator on that. But if you did that, that would be negative 5. And the negative 5 is what we got anyway. Okay? So negative b over 2a gives you a simple, fast way to find the x value of the vertex. Plug that x value into the function to get your y value like that. Okay, yes?
Is there some cases where you can only use 1 or can you use
No, you can always do negative b over 2a.
Okay.
You can always complete the square. There's never a time when you couldn't use one of those two methods. Okay? Okay, let me go ahead and do the intercepts. And you need to kind of go to maybe down the bottom of the page for that. So the next thing we want to do is we want to find the x-intercepts. So remember, when we do an x-intercept, we set the function f of x equal to 0 and we solve an equation. Okay, so go back to the beginning of the problem where we had f of x is negative 3x squared plus 6x minus 8. Replace f of x with 0. Now what we need to do on this is we need to either go to the quadratic formula or you need to factor it. Okay, and it's really your decision on what you do on that one. This one, either way is okay. All right, let's just go to the quadratic formula on this one also. Okay, so when I go the quadratic formula, I'm going to have negative b, so b is 6. Then I'm going to have plus or minus square root of b squared. Then I'm going to have 4a times c, right? There's b squared minus 4ac. And then all over 2a, and a is negative 3. Okay, so we want to get that worked out as far as we can and see if this time we have an x-intercept. You can use your calculator to help with a few things if you want. Okay, and if you do this, we might end up with kind of the same kind of situation on this problem. So if you wanted to, on your calculator, you could just type it in exactly as it is. You could do 6 squared minus 4 times negative 3, and then times negative 8, or you can do that by hand, and we get a negative again. Okay, if you get a negative, that kind of makes it simple. So what do we know about the x-intercept? If you can't do a square root of a negative number, what does that tell you about the x-intercept? We don't have one, right? That's what happened on the last problem, okay? So that right there is going to tell you that we have no x-intercepts. Just coincidence that we have two problems that way. You can have x-intercepts if that equation can be solved, okay? All right, so see, that's good on that one. It's just best to just go immediately to your quadratic formula on that, okay? So now what you want to record in the answer blank is that we have none for an x-intercept. And I already knew that, and I think it's okay as a student that you already know that too. And let me explain why. If you look at this thing right here, if you look at this original problem, you have a negative in front of x squared. If you have a negative in front of x squared, that means the thing goes down. Automatically, the thing's going down. If you look at where our vertex is, look at this, okay? You know that if the vertex is 1, negative 5, if the parabola is going down, there's no way you cross the x-axis, so automatically you would know that answer is none. You see what I mean? So you wouldn't have to even show any work in that case. You don't have to, okay? All right, so let's go ahead and let's do the y-intercept next here. Okay, so on the y-intercept, what you always do on the y-intercept is you set x equal to 0. It's always easier to find a y-intercept. So you find f of 0. Okay, so plug in where you see an x in the original equation, plug in a 0. So we have negative 3 times 0 squared plus 6 times 0 minus 8. With a little practice, you'll be able to tell what the y-intercept is in your head. So what's the solution to all this arithmetic? What do you get just in your head? Negative 8, right. That goes to 0, that goes to 0. You're left with negative 8. So that means your y-intercept is 0, negative 8. A y-intercept is always 0 for x and then whatever y is. Okay, so this problem will work out a lot like the last one. Now we've done all the work of the problem. The rest of it's automatic. Now you got to think about just how your graph's going to go. Okay, so that's how your y-intercept goes. Now what you want to do from here is you want to go ahead and plot that point. Okay, so we've already got our vertex 1, negative 5. Just go to 0, negative 8 and label that. And then it's a good idea to do your axis of symmetry. That's the dashed line that goes through the vertex. Okay, and then what you're going to do is that other point. Okay, where's that other point going to be? So from the vertex, we're going to the left one. So now if you just go to the right one, then that other point would be symmetrical about that. That would be the point 2, -8, like that. That's the benefit of the axis of symmetry. Then you can figure out one more point on there. So that's what your graph looks like, is like that. Okay? So again, does everybody see I have 0, -8? That means that I'm 1 to the left of the vertex, so I need to go 1 to the right of the vertex to get that point that's on the other side of the symmetry line. Okay, that's what that means then. Okay, all right. Now let's go ahead and let's just answer the rest of this. Okay, we know that our axis of symmetry, that's always x equals whatever the x value of the vertex is. So that's x equals 1. The domain is always all real numbers on a quadratic function because x can be anything. How about the range? What's the range? You're going from way down. What's the highest value of y? -5. Okay, so we would say -infinity to -5. Okay, like that. Okay, and then the increasing, we've kind of learned how to do that earlier. The increasing would be this part of the graph. And again, we name that with x values. So we would say from -infinity until we get to 1. Remember, it's the x values. From -infinity to 1 is where the graph is increasing. And then we're decreasing the rest of the way. So that would be from 1 to infinity, like that. Okay? Now, those two problems that I did there worked out the same way. The completing the square was more difficult on this one, but everything else was pretty much the same thing. Okay? Any questions? Okay, so I want you to go ahead and go to the next page. I want to kind of give you an opportunity to work together on a few problems here. And really just this one problem. Let's go ahead and go to the next page and see what you can do on that. Okay, and I'll come around and help. You can work together and kind of pair up and compare answers as you're going through these then. Okay, I do want you to try to complete the square and do -b/2a. When you're doing your homework, it's up to you which way you decide to do it. But for this example, I'd like you to do that both ways, okay? All right, and I'll come around here in a little bit and see how we're doing. Okay, so let me go over the completing the square. I kind of helped a lot of people with completing the square on this, and the issue that a lot of you had was you weren't really setting it up correctly. When you complete the square, put the x's together and leave a space right there. Okay, that's what you want to do. So when you complete the square, you're taking half of the 6, which is -3. Then you square the -3 to get a 9. You do that. All right. Now, see, this is why a lot of you are missing this, because you weren't doing it right. You complete the square inside the parenthesis, and then you have to do the opposite out here to balance it out. Okay, so that's how that goes. That's what you want to have on your paper. And then you go through and you factor this. So this will factor as x and x, -3 -3. Those things turn out to be the same. -2 minus 9 is -11. So when you complete the square, what you should have come up with is f of x equals x -3 to the second -11. Okay? So I think a lot of you were a little shaky on how to do that. So now what this means you're going to the right 3 and you're going down 11. So that would mean your vertex is to the right 3, so that's 3, down 11 is -11, like that. So that's your vertex right there if you complete the square. Okay, let me go over the -b/2a part. And that's a little bit easier. So again, you have f of x equals x squared minus 6x plus 9. B is -6, a is 1. So when you do -b/2a, you're going to have -6 over 2 times 1. That'll be 6 over 2. So that gives 3. Okay, so we're going to get 3 for our vertex value. Okay, then what you want to do is you want to do f of 3 to find the y value. Okay, so plug the 3 into your function. So you'd have 3 squared minus 6 times 3 plus 9. That would be 9 minus 18 plus 9. Hold on. Oh, I know what I did. Putting it in the wrong place. That original problem had a minus 2 in it, is what it had. Okay, so we had x squared minus 6x minus 2. So now you would do f of 3 would be 3 squared minus 6 times 3 minus 2. That would be 9 minus 18 minus 2. So that would be negative 11. Okay? Okay, and that wasn't a big problem, I don't think, for anybody is doing that. So you put it together, you have your vertex, you have x is your, x value of the vertex is 3, y value is negative 11. Okay, so let me just kind of pause there and see if there's questions about either of those techniques that we're doing on finding the vertex. Any problem? Okay, all right, and you can do it either way. So the other thing we want to kind of go through and look at is the x-intercept. I had to help several of you with this. When you have the x-intercept, you always set f of x equal to 0. There's a few issues that are going to show up in your quadratic formula then. So you want to use the quadratic formula on this. Okay, so if you do that, in your quadratic formula, you would have negative b plus or minus the square root of b squared, and then 4ac, and then all over 2 times a. So you want to get all that arithmetic put together correctly. So we would have 6 plus or minus. Now, if you work out what's under the radical, you're going to get 44. You could use your calculator to help you with that if you wanted to. Over 2. All right. Now, from here, you want to break this down like this. You can break it down the square root of 44 into 4 times 11, like that. Okay, so we've learned how to deal with the radicals when you do that. So what we would have then is we'd have 6 plus or minus 2 radical 11 over 2, like that. And if you didn't get this, you want to get this written down. And then we have 6 over 2 plus or minus 2 root 11 over 2. Okay, so what we've got now is we've got 6 over 2 is 3, 2's cross out, so you have 3 plus or minus square root of 11 like that. Okay, so that you have to work through the quadratic formula like we learned earlier in the semester. Now you've got your intercepts. Okay, and what you want to do when you write your intercepts is if you didn't write it this way, write it this way. You want to write both of them. You want to write 3 minus root 11 comma 0. If you didn't write it that way, write it that way. Okay, the other one is 3 plus root 11 comma 0 like that. Okay, so that comes from the quadratic formula, getting those intercepts. Okay. Okay, y-intercept. What do I do to find a y-intercept? Say something. Plug what in? And for x. Okay, good. So we do f of 0, and your original function was x squared minus 6x minus 2. So you end up getting negative 2 as your y-intercept. It's real easy to find a y-intercept. So that y-intercept is going to be 0, negative 2. Okay? So now I can record that, and the rest of it, once we got that, we can kind of put the rest of it together then. Okay, any question on the y-intercept? How do you remember that, by the way? It's the opposite variable. When you have a y-intercept, you're on the y-axis. And x is 0 when you're on the y-axis. Okay, so that would be the work of how you would get the key details of the problem. The other thing that I would recommend that you do for the accuracy of your graphing is take your calculator and turn these things into decimals. So if you do 3 plus the square root of 11, okay, you're going to end up getting, that's going to be about 6.3. That's where you're going to cross the x-axis. If you do 3 minus the square root of 11 on your calculator, that will give you about negative 0.3. So it's important you do that so that you can accurately locate where the intercepts are, okay? So now as far as your graph goes, what you want to do is on your graph, you wanted to plot the vertex, so over 3, down 11, so that's 3, negative 11. And then your intercepts, you have one that's at about 6.3, just kind of estimate it. And I would write that on my paper as 3 plus root 11, 0 like that. If you didn't write it that way, you should. The other one would be negative 0.3, so it's over here. And I would write that one as 3 minus square root of 11, 0 like that. Okay, the other thing we got was the y-intercept was 0, negative 2. So you want to plot those points. And let me zoom on that a little bit, see it a little bit better. So I've got my vertex, my intercepts. Now, once I got that, then I can connect the dots into that shape like that, and then that's a real accurate graph, okay? But if you end up having decimals as your intercepts, you just get that on the calculator, okay? But I want for your answer to the intercepts 3 minus root 11, 0, and 3 plus root 11, 0. It's got to be like that, okay? So here's what you should have got on the rest. Domain is all real numbers. It always is. The range on this would be bracket, negative 11, infinity. The lowest y value is negative 11. The equation of the axis of symmetry is x equals 3. That's just x equals to whatever the x value of the vertex is. And then increasing would be from 3 to infinity. And then decreasing would be negative infinity to 3 like that, okay? So again, what you're looking for in increasing and decreasing is you're looking at the x value like that. Okay, and then you can draw, if you want to, you can draw your axis of symmetry through that kind of like that, okay? So what I want you all to understand is every piece of this problem is something you've done before. Did you realize that? You've done the quadratic formula, okay? We have even completed the square before. We learned how to do that before, okay? So everything, it's an application of things we've done before, so you'll be kind of reviewing some of that as we go, okay? All right, let's go ahead and take 10 minutes. Come back at 1:15. I will give your test back and talk about that a little bit when you get back, and then we're going to finish this and start working on next section, okay? So you did pretty good.